Welcome to Lecture 1, Server Virtualization. In this lecture, we'll discuss about server virtualization. Server virtualization refers to the partitioning of a single operating systems are not modified for the purpose of virtualization, and the guest operating systems think that they are running directly on the hardware of the host. In full virtualization, the hypervisor does the binary translation of all the privileged instructions on the fly and caches the results for future use. And the non-privileged instructions are executed directly on the hardware without any modification. And the hypervisor. The guest operating systems are modified to replace the non-virtualizable privileged instructions with calls to the hypervisor known as hypercalls. The guest operating systems then communicates directly with the hypervisor through hypercalls. In addition to this, there are hypercall interfaces provided by the hypervisor to carry out critical operating system also introduces some problems in production environments that are related to support and maintenance, as para-virtualization require deep operating system modifications. Let's talk about hardware-assisted virtualization. Hardware-assisted virtualization refers to CPU technologies that provide enhancements to assist the virtualization software or hypervisor. The hardware vendors Intel and AMD introduced the hardware-enhanced virtualization technologies into Before we talk about operating system level virtualization, it would be helpful if we understand a couple of terms such as process and kernel. A process is a running instance of a program. The program that constitutes the core of an operating system is called kernel. The kernel is the controller of all the processes and controls everything. Now let's look at operating system level virtualization. In an the virtual environments replicates the components of the host operating system. So if the host operating system is Linux, then all the virtual environments can only run Linux or Linux distributions, but not other operating systems with different kernels like Windows. Since the kernel of the host operating system is shared with other processes, the operating system level virtualization is also known as shared kernel virtualization. The advantage of operating system level virtualization is that there is little or no virtualization overhead, and it is ideal for situations where all the physical servers run the same operating system. Examples of operating system level virtualization are OpenVZ, Solaris containers, and FreeBSD jail. That brings us to the end of this lecture. In the next lecture, we'll discuss about desktop virtualization. Thank you for watching.